Let's briefly discuss the network types you should know for the A+ exams. A LAN, or local area network, is a group of computers and other devices usually located in a small area, like a small building, a small office, or a home office. The computers all connect to a central connecting device, such as a switch or a wireless access point or a SOHO router. And that router allows these computers access to the internet. Generally, there are no other routers internally. Technicians often use terms such as connect the computer to the LAN or how many computers are on your LAN. The LAN is usually based on a network design called a star topology. So you have all your devices connected to a central connecting device, again, such as a switch, an access point, or a SOHO router. But remember that a LAN is normally in a small geographic area. It's in one building. Contrast that with a wide area network, or WAN. A WAN is a group of one or more LANs over a large geographic area. Let's say a company has 2 or 3 local area networks, maybe one in New York, one in Los Angeles, one in Dallas. Connecting these together would result in a wide area network. To do this, we would require the help of an internet service provider, an ISP. This provider would create the high-speed connection that's required for the two LANs to communicate quickly. Each LAN would require a router to connect to the others and connect out to the internet. And we'll talk about the different types of internet services in a separate video. Another network type is the Metropolitan Area Network, or MAN. This is a smaller version of a WAN. It's also known as a municipal area network. This is when a company has 2 offices, quite often in the same city, and wants to make a high-speed connection between them. It's different from a wide area network in that it is not as large of a geographic area, but it's similar to a wide area network in that an ISP will be needed for the high-speed link. And you'll note here that I added routers, one for each LAN. And they're required to connect the 2 LANs together over that high-speed link. There are also campus area networks, or CANs, where you might have several buildings in the same area on one block or spanning a couple of blocks. And it could be within a university or a large organization or corporation. The next is the Wireless Mesh Network, or WMN. Generally, a mesh means that you have something that connects out to everything else. And when it comes to wireless mesh networks, we have wireless access points, or nodes, that have multiple connections out to all of the other wireless access points in a mesh pattern, or a matrix. Implementing a mesh can be very helpful with redundancy and availability. In a WMN, multiple wireless access points are used on the same channel. So this allows for greater coverage in larger environments. As mobile devices move around the building, like your laptops and your tablets and your smartphones, as they move around the building or buildings, they quickly transition from one access point to the next. Now, in a WMN, the APs, the access points, they don't have to be physically cabled to a wired port, like, say, with a traditional access point or a wireless extender. However, all of these access points that you install must have a built-in mesh capability, which will often mean increased cost, and you'll have to stick with the same manufacturer of all devices, most likely as well. But this technology can provide a more efficient solution than the traditional wireless extender, as well as centralized management if that's required. So you'll see this type of thing in larger infrastructures, but you'll also see it in simpler SOHO environments with more basic devices, where it might be referred to as mesh Wi-Fi or Wi-Fi mesh or Wi-Fi ad hoc or some similar name. On a slightly different note, a personal area network, or a PAN, is a smaller computer network used for communication by small computing devices. Take this to the next level by adding wireless standards such as Bluetooth or wireless USB connectivity or Zigbee or Z-Wave, and you get a wireless PAN or WPAN. These networks are sometimes ad hoc, meaning that there's no one device controlling all of them, no server, no access point. However, they can be controlled by a hub and gain access to the internet from that device, especially if you're dealing with Zigbee or Z-Wave and home automation and things of that nature. Now, we don't use the term PAN too much anymore, but it is on the A+ objectives. A SAN, or Storage Area Network, is a dedicated network designed specifically for the storage of data. Moreover, it's a network of data storage devices that are connected together on a typical LAN or by way of special high-speed fiber optic connections, such as Fibre Channel. The network consists of components such as network-attached storage devices, or NAS devices, RAID arrays, tape backup devices, and a switch to connect it all together. The idea is to allow for high-speed access to data without bogging down the servers that control and request that data. So we may have separate servers elsewhere on the network, but this SAN is a network unto itself that has perhaps a Fibre Channel switch, Fibre Channel storage, maybe additional network-attached storage backup devices, and perhaps RAID devices, RAID 0, RAID 1, mirroring, RAID 5, striping with parity, and so on. So what this does is it separates the server's functionality from the actual data storage. And it allows for an administrator to potentially make the data more secure, more redundant, and highly available. And Fibre Channel is widely used for high-speed fiber networking and really has become a standard in enterprise storage area networks. Let's go ahead and review the network types briefly. We have LAN, which is local area network, WAN, which is wide area network, MAN, which is metropolitan area network, WMN, which is wireless mesh network, PAN, which is personal area network, and SAN, which is storage area network. And that's it for this video.